Now, let's introduce today's speaker. Jennifer German is a NASA Solar System ambassador, a former lead software engineer, a current medical student, a mother of two, and a hopeless space geek. She first became interested in space in second grade. Since then, I've lost my line there. For example, looked for Halley's Comet, followed the development of the Hubble telescope and construction of the International Space Station. Jennifer loves space exploration and tells everyone who will listen about the latest planetary news. She points out constellations and passes on tips for identifying stars and not stars to anyone who asks. She also interned at Biosphere 2 for one of the best summers of her life. Hello, Jennifer, and welcome. Thank you so much for being here.
I'm happy to. Let me switch to the presentation real quick. Hello, everybody. So, as was just introduced, my name is Jennifer German. I am a NASA JPL Solar System Ambassador, usually to Michigan, but today on the internet to Washington. And Aaron S. Wolf, who is a planetary scientist I know, contributed to the Mars portion of this presentation. But we are all volunteers and very happy and excited to be sharing this stuff with you. So, Artemis. Firstly, to understand what's going on with the Artemis program, you need to know a little bit of history. Project Mercury was NASA's first program, which put 6 manned flights into space from 1961 to 1963. The name Mercury comes from Greek mythology. Does anybody out there know who Mercury is? And if you do, please just type it in the chat.
So we've got nobody answering so far, Jennifer. You might have them stumped.
It's okay. They'll have a chance to answer more later. I will answer right now. So Mercury was the messenger of the gods and was incredibly fast. God of communication, very good. Thank you, Susan. Both the planet and NASA's program were named for this god. Project Mercury was all about what can we do and how can we do it. It had 3 very specific objectives were reached. The first was orbiting manned spacecraft around the Earth. The next was to investigate man's ability to function in space. And lastly was to recover both man and spacecraft safely, all of which it did. Project Gemini was the era of twos, which from 1965 to 66, so 2 years, defined and tested the abilities NASA would need to go to the moon. The word Gemini is Latin for twins. Project Gemini was not just NASA's second human spaceflight program, but was about 2 astronauts launching together, and then one of those 2 leaving the safety of the spacecraft, testing an astronaut's ability to fly space missions up to 2 weeks long, 2 spacecraft meeting in space and docking, and it flew 10 manned missions, achieving all those goals in under 2 years. After that, the Apollo program launched 11 manned missions from 1968 to 1972, which was after losing 1 mission and the 3 astronauts to a fire in 1967. And this part's actually important. If you saw the movie The Martian, you probably remember the line, NASA hates fire. Not only is that true, Apollo 1 is where that comes from. NASA always takes human life very seriously and learns from any loss of life. Okay, moving on. So Apollo, this is for the audience again, also comes from Greek mythology. Who was Apollo? Which god? Yes, Thank you, Janice and Susan. And Robert, God of the Sun. Claudia. All right, I got to click away, sorry. So the story goes that the NASA director of spaceflight at the time the moon program was being created, he was reading a mythology book and thought the image of Apollo riding his chariot across the sun was appropriate to the grand scale of the proposed program. And so he named it the Apollo program. Of those 11 successful manned missions, Apollo 7 and 9 were actually only Earth orbits. They did not, but they were not meant for the moon. Instead, the astronauts tested equipment, the spacecraft, and the maneuvers that would be necessary for when we were at the moon. Apollo 8 and 10 were moon orbits with astronauts, and the pictures that were taken during these missions were invaluable for landing sites for the future missions. Apollo 11, 12, and 14 through 17 were moon landings of astronauts. So 6 missions, each of which put 2 men on the moon, while a third astronaut waited in orbit to retrieve the other 2. And of course, Apollo 13 went from a planned lunar landing to only a lunar flyby due to a very serious malfunction. Not the focus of this presentation, but there is both a great documentary and a pretty good movie that you can go see about Apollo 13. And then that was it, at least for the moon. It's been 50 years. Obviously, NASA has been busy with other programs. Most notable for this presentation was STS-107, which, known to the rest of us as the Space Shuttle Columbia disaster. In February of 2003, an impact from foam falling off the main rocket's external tank as the shuttle launched off of Earth damaged the orbiter's heat shield. During re-entry, unfortunately, all 7 humans on board were killed and the shuttle was lost. The falling foam problem had been known by NASA for a few years before February of 2003. After the loss of the Columbia and her crew, NASA was informed to stop reliance on past success as a substitute for sound engineering practices and to ruthlessly seek and eliminate safety problems to ensure astronaut safety in future missions. So, shuttle era. So now we come to Artemis. This program has not yet put any crewed flights in space. Artemis 1 launched and landed in 2022. It's now 2024. So we'll talk about that in a few minutes. The name Artemis, again, comes from Greek mythology. All right, last question for the audience for a little bit here anyways. Who was Artemis? Oh, and I've lost my access to the chat, so if someone could help me out.
Yeah, I'll let you know if anybody types in anything, Jennifer.
Thank you.
So who is Artemis? Got Robert saying goddess of the hunt.
Mm-hmm.
And then Saul says moon goddess.
Yes.
So we're going with Saul's answer, moon goddess.
Oh, no, both are correct.
Oh, both are correct. And then one last one from Susan, Apollo's sister, but don't know what she ruled. And then twin sister of Apollo.
Yes.
Shirley. All right, a lot of good answers.
Oh, you all are doing wonderful. Yes. Artemis is the twin sister of Apollo and the goddess of the moon and the hunt. Therefore, NASA chose to name the current program Artemis to be both the sister program to Apollo and to represent sending the first human female to the moon. All right, video time.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here.
And that is why we're going back to the moon now, to practice for going to Mars. The moon is only 3 days travel instead of 6 months, and that 6 months is assuming we get the expected advances and we have ideal planetary alignment. The communication delay with the moon is extremely shorter than the delay with Mars, so we will be able to monitor and manage missions much easier, making it the ideal testbed before Mars. With Apollo, the USA had been in a race to the moon. Now, with Artemis, it's more than just a race. This time, it's for establishing a long-term presence on the moon. The Artemis program stands on the shoulders of the Apollo program, but there are differences. We're going to go through those differences. So first, as I've said, instead of temporary research, we're working on sustainability now, learning how to live and work at the moon. Humans will move constant presence in orbit, which is on the International Space Station. They will move to a constant presence in lunar orbit via the next step in exploration, the Gateway Space Station, which will orbit the moon. So back here, you can see where the Orion spacecraft will dock with Gateway. And here in front is where the human landing system is docked, which will shuttle astronauts from Gateway to the moon's surface and then back up. The moon will also become the gateway to all of humanity's deep space exploration, hence the name of the proposed lunar orbiting space station being Gateway. So, we're also going to a different location on the moon. The Apollo missions all landed on the middle third of the moon, and so they were all close to the equator, and they were all on one side, one hemisphere of the moon. So when I cover these sites and the spaces in between them, you can see how much of the moon is still unexplored. Artemis missions, and later the Gateway Space Station, will orbit the moon pole to pole, so seen there in red. I don't know if you can see my pointer, instead of around the equator. The Artemis missions will land at the moon's south pole. And why the South Pole? Well, the peaks of the moon in the South Pole are always in sunlight. So we won't need any artificial lights to see, and there's plenty of solar power available there. While the South Pole itself is in near constant sunlight, the basins of the craters there are in constant or permanent shadow. And it is in those special craters that scientists believe there is water ice accessible from the moon's surface, which will be needed to make oxygen for breathable air. So the South Pole gives us two essentials that we need. Another difference between Artemis and Apollo is the diversity in the crew. The current NASA astronaut corps more closely reflects the nation it represents now. It's made up of 38 active astronauts, plus 10 more astronaut candidates in training as of January 2024. In December of 2020, NASA announced the 18 members of the astronaut corps that were assigned to the Artemis program and would begin training for moon missions. 9 men and 9 women. 4 of the men and 5 of the women at the time had already flown in space, either on a space shuttle or to the International Space Station when they were assigned to the Artemis program. In the last 3 years, 8 more of these 18 have been on missions to the International Space Station, courtesy of SpaceX. As of January 2024, 1 more of these 18 is slated to fly on the upcoming SpaceX 8 mission later this month, so on February 22nd. And that will leave only 1 space rookie in these ranks. However, his astronaut career path appears to be taking him into leadership at mission control on the ground and away from spaceflight, so it's probably not going to be a problem. In April of 2023, NASA announced the 4 astronauts assigned to fly around the moon on the Artemis 2 mission. 3 of these astronauts are from NASA, and 1 is from CSA, which is the Canadian Space Agency. We do not yet know which 2 of these 18 astronauts will be assigned to Artemis 3 as the next humans to walk on the moon. But these astronauts are the representations of you 20 and 30-something-year-olds, and maybe a couple 40-somethings. You all are the Artemis generation. And I can't see you all, but I hope somewhere out there, all of you in the listening right now who are growing up right now, you are the Mars generation. Some few of you will grow up to become astronauts, and sometime in the 2040s will orbit and hopefully set foot on Mars. Okay, next video.
The dawn of Orion and a new era of American space exploration.
Artemis will demonstrate a new path to the moon for this generation.
Artemis 1.
An uncrewed test flight will be a final proving of every system,
Every component.
in the harshness of space.
A mission that, when successful, will open the door for the moonwalkers and lunar experiments
that so many have hoped and dreamed about.
We are going.
And indeed we went. Artemis 1 splashed down back here on Earth, December 11th of 2022. So let's talk about the Artemis 1 mission for a couple of minutes now. Artemis 1 was a test flight to prove that NASA can fly crew to the moon and back. Its #1 priority was to test the Orion heat shield on real-world entry to Earth, because we had not been able to do that before. It's about 5,000 degrees Fahrenheit on re-entry, which is almost as hot as the surface of the sun. So not something we can reproduce here to test. While the Orion capsule performed exceedingly well from launch to landing, it was later found that its heat shield lost more material than computer models had predicted, and irregular charring of the material had occurred. The other 2 main goals of the Artemis 1 mission were to operate in a spaceflight environment and to successfully retrieve the spacecraft and its crew. Now, wait. Didn't the woman in the video just say that Artemis 1 was unmanned? So what do I mean by crew? Not humans. There were actually 5 special passengers aboard Artemis 1. Snoopy. Snoopy was both NASA's special passenger and the zero gravity indicator for the flight. So Snoopy was the one thing that was not tied down or belted down or secured in any way, so that when he started floating, they knew they were in zero gravity. This was Snoopy's first time around the moon, but Snoopy had been the face for NASA's safety campaign during the Apollo missions. Shaun the Sheep, ESA's special passenger. Just as NASA has a history with Snoopy, ESA has a history with Shaun the Sheep. ESA is the European Space Agency. The Moonikin. The what? Okay, let's see. What is this? Commander Moonikin Campos is its name. It is a full-size weighted male-bodied mannequin which we sent to the moon, hence calling it the Moonikin. The Moonikin wore the crew Aurora. One more try. The Moonikin wore the Orion Crew Survival System suit, seen there in orange, the same spacesuit that Artemis astronauts will use during launch, re-entry, and other dynamic phases of their missions. Commander Campos was equipped with 2 radiation sensors and had additional sensors under the headrest behind its seat to record acceleration and vibration data. And that data will be used by NASA to help protect astronauts during Artemis 2 and beyond. Lastly, but by no means leastly, were Helga and Zohar. These are twin mannequin torsos and heads only. They're made of materials that mimic the soft tissue, organs, and bones of a woman. Their insides even resemble human lung and brain tissue in order to test how radiation passes through the human body. The torsos have more than 5,600 sensors. They have 34 radiation detectors, and that is to measure how much radiation exposure occurs within different organs during missions. The mannequins are part of MER, which is a collaboration between the German Aerospace Center, the Israel Space Agency, NASA, and many institutions across multiple countries. Zohar, here in front, wore AstroRad, which you can see in black. That is a radiation protection vest. And the point was to test how effective the vest could be if future crews encounter a solar storm. Helga was unprotected for comparison's sake. You know, I keep talking about all the safety steps, features, and procedures that NASA takes. Why do I keep saying that? Well, for one, it's true, right? And secondly, it explains why Artemis's launch has been delayed 2 years, at least 2 years. Recall I told you that the reason the Columbia Space Shuttle and its 7 astronauts were launched was due to a breach in the heat shield. The Artemis 1 mission, wildly successful, and yet, on inspection after returning to Earth, the Orion's heat shield was found to have lost too much material and in unexpected ways. The potential for unknown problems is exactly why NASA tests rockets and spacecraft before putting humans on them. NASA learns from what happens, and Columbia is why Artemis 2's launch is so delayed. Despite the Orion spacecraft itself and the artificial mannequins inside surviving, NASA is meticulously seeking and removing potential safety problems before adding 4 astronaut lives onto their test missions. All right, Artemis 1. Over the course of 25.5 days, NASA tested Orion in the harsh environment of deep space, and it was an overwhelming success. The data collected from the heat shield, from the 3 mannequins, all of it is now being analyzed and used to make the Artemis 2 mission a success also. Artemis 2 doesn't have a logo yet, so we're going to stick with the overall Artemis logo for now for the rest of this presentation. Artemis 2 will be a second test flight, the first with crew on board. As such, the mission will test the critical environmental controls and life support systems required to support astronauts long-term. And its #1 priority is to confirm all of the spacecraft's operations, systems, our work as designed with crew aboard in the actual environment of deep space. Okay. What you see here is a diagram of the rocket and spacecraft's flight plan for Artemis 2. After a successful launch and separation, again, I don't know if you can see my mouse, there is the rocket. The Artemis rocket's job is done. Orion then follows this green path and orbits the Earth, passing equipment and readiness checks. Finally, it will leave orbit, loop around the moon in a flyby, and before making one complete orbit of the moon, will come back home to Earth. So, back to talking about the Artemis program overall. We are still in phase 1. We have completed the Artemis 1 mission. Next up will be Artemis 2, which will have humans on board and orbit the moon. That mission is currently scheduled for September of 2025. The Artemis 3 mission will land 2 humans on the moon's surface near the lunar South Pole. NASA has promised one will be a woman and one will be a person of color. That is currently targeted for September of 2026. In the same time frame, so from 2025 to 2028, SpaceX will start delivering pieces and equipment from CSA, ESA, JAXA, and the United Arab Emirates into orbit around the moon. These will be necessary parts for staging and building the Gateway Space Station. Then, Artemis 4 will be the first mission that sends astronauts to assemble the Lunar Space Station, and that is on track for 2028. Artemis 5 and 6 will continue and hopefully complete the space station's assembly. All three missions are also expected to send astronauts to the moon's surface and retrieve them via the human landing system component of the new space station. Now to the important stuff, right? What will it be like for the astronauts? Landing on the moon is only a few hours of their trip. What will it be like as they travel on Orion for 10 days? What will it be like to be stationed on the Gateway Space Station, to live there, even temporarily? And the even more wondrous question, what will it be like for humans on Mars? So let's start with NASA, back in time. NASA had been blessed to have a set of identical twins pass all the requirements to join the astronaut class of 1996, and then pass the 2+ years of training to become astronauts. The Kelly twins each flew into space 4 times, but never together, just in case. So when the topic of human travel to Mars became a serious goal, NASA seized their only opportunity for the medical field coveted twin study. They asked Scott to spend the year 2015 in space, while Mark spent the same year on Earth doing all the same things Scott did. Well, okay, except for the 3 spacewalks. The results of the twin study were remarkable. There have been at least a dozen papers. 1 summary paper has been published using the data the Kelly twins provided NASA. But medical studies and research results don't tell us, what is it like? How does it feel? What happens to you? Scott Kelly has published 5 books about his life leading up to and during his 340 days living in space. And as a side note, Snow Isle Libraries has all 5 in their collection, including 2 of them in Spanish. Just saying. So I read a couple of them to get his own words for you for this presentation. He says, after my year in space, I stretched almost 2 inches and my eyesight got worse. You can see he's even wearing glasses on the space station there. Scott wrote this in his book, My Journey to the Stars. NASA then added that Scott had a 7% reduction in his body mass, which for him was 15 pounds. So he got noticeably taller but I'm mostly back to normal, Scott assured everyone after 6 months back on Earth. In his year in space, Scott Kelly came into contact with only 12 humans while he was living aboard the International Space Station. He wrote, I miss fresh air and the feel of the rain on my face. I miss hugging my daughters. And the Earth meant everything to the crew while we were so far away. We loved to look out the windows at our beautiful planet. We hope our photos of Earth would inspire people to help protect our amazing home. So, of course, there's no gravity in space. So everything floats, not just the astronauts. Scott wrote, floating sounds like fun, and it is. But tools you are using float away, and that can be so annoying. Even your body can float away when you're sleeping. However, he also writes in his book Endurance that because there's no gravity, every surface is storage usable. Walls, the floor, the ceiling, all packed with equipment. The lab looks cluttered, but the things I use the most, I can put my hands on in seconds. There are also a large number of things I would not be able to put my hands on if asked. Because without gravity, items wander off regularly. And the ground, which means ground control back on Earth, will often email us wanted posters regarding lost objects, like the ones the FBI's put up in post offices. Occasionally, one of us will dislodge a tool or a part that has been missing for years. 8 years is the record so far for a missing object reappearing. Missing objects are often recovered in the many International Space Station intake vents, which you can see here, but not all of them end up there. Astronaut Tom Jones, who this is not, in this picture is Chris Hadfield. Just wanted to point that out. Tom explained in a September 2010 article that in free fall, objects have an uncanny ability to escape and then evade search. According to Don Petit, who lived on the International Space Station in 2003, part of the problem is the terrestrial habit of looking for lost items down at your feet. In weightlessness, this is not an effective search strategy, he says. And even after months of living in space, that was one reflex he never lost. The International Space Station isn't the first to be plagued by lost items, and so we can assume this aspect of spaceflight on Orion and the Gateway Space Station. Tom recounts, anyone who has ever flown on the space, it was built by the same engineers who brought us the sock-eating clothes dryer. And when Sonny Carter flew aboard Discovery on STS-33, his wristwatch went missing, and the crew could not find it. Back on Earth after landing, technicians had no luck either. It was on Discovery's next flight that Steve Hawley, an astronaut, removed some flight deck panels for maintenance and was surprised to find Sonny's watch, plus a pack of salt tablets and a hairbrush. The message is that lack of gravity causes more lost items than gravity on Earth does. What other aspects of space life can astronauts expect? In 2010, Chris Hadfield, and in 2012, NASA's Sunita Williams, each made a great series of videos about living in space, from eating to sleeping to grooming to using the bathroom in outer space, even exercising and playing. You can find them all on YouTube. Just search for these phrases I have up here, Suni Williams Station Tour, and you will find multiple videos that are by NASA, and there you can see what she looks like. Also, An Astronaut's Guide to Life in Space, and you should find a playlist by CSA Chris Hadfield. Again, CSA is the Canadian Space Agency. For this presentation, I picked only one of the most basic human experiences to share with you, eating. And that's because really I want to get to what is expected to be like getting to and being on Mars. So, here we go.
Hello, and welcome to the International Space Station. My name is Scott Tingle. Here on the space station, we live in a microgravity environment, which makes eating here a very unique experience. To stay healthy, we have to maintain a nutritious diet, just like we would back on Earth. Let's go take a look at some of our food and drinks and check out our meal preparation area. During long-duration spaceflight, we have to make sure that we receive enough energy, proteins, and vitamins. Our food lab back on Earth makes sure we get plenty of each as they carefully prepare, test, and package everything. We combine all of this excellent nutrition with exercise to ensure our bodies stay healthy and strong while we're here. We eat 3 square meals a day, just like we do on Earth, and maybe throw in a snack or two. One of my most favorite foods to eat are natural raisins. Here on Space Station, we have to keep our calories up if we want to get all our work done. And the carbohydrates in these raisins really help. And they're kind of fun to eat, too. And how do we stay hydrated in microgravity? With these special pouches. They're filled with water, and we use a straw that has a one-way valve that prevents water from floating out of the pouch while we're not drinking from it. Here's a liquid drink. This is a tropical punch for today. I love drinking fluids on station. Here on station, we have a pretty cool food preparation area. We have a place to get fresh water for us to drink or to put in our rehydratable foods. And we also have an oven to put food in. We pick out some of our favorite foods, chicken fajita for me. Put it in the oven. Close the door and turn it on. In about 15 minutes, I'm gonna have a warm meal. Thanks for exploring a little nutrition with me. I'm gonna send you back to Earth so you can create your very own astronaut menus. See you again soon.
Okay, so we know what everyday living in space looks like. I mean, it does look like a lot of fun, but they're working up there too. As Scott Kelly's mission showed, things change over long periods of time. Both NASA and Roscosmos have since run missions with astronauts living on the International Space Station for what's called extended stays. First, I would be greatly remiss if I didn't tell you that cosmonaut Mikhail Kornienko also spent the same year on the International Space Station in 2015 with Scott Kelly. I think his name tends to be left off because of the novelty of the twin scenario. In 2017, astronaut Peggy Whitson spent 9.5 months on the International Space Station, and NASA ran all the same tests, procedures, and data gathering on her that they had done on the male Kelly twins 2 years earlier. She was originally only supposed to spend the typical 6 months in space, but Roscosmos decided for budget reasons to only send one cosmonaut on the subsequent Soyuz launch, which left an empty seat for both launch and return. NASA seized that opportunity to extend Peggy's mission by 3 months, which gave them the longer duration time they needed for the tests they wanted to run on a female. Next up was Christina Groth. She was up for a little shy of 11 months, crossing 2019 to 2020, but her mission was focused on testing technology that would be needed to support humans instead of human biology. Then NASA astronaut Mark Vande Hei and Roscosmos cosmonaut Pyotr Dubrov, I hope I said that right, broke Scott Kelly and Mikhail Kornienko's record for consecutive time on the International Space Station by 15 days. Vande Hei's mission included testing an enhanced spaceflight diet to see if it could help humans better adapt to long-term life in space. And yet, while all these missions I've mentioned so far were called a year in space, none actually lasted a full 365 days. There were 340 days and 355 days or less. It wasn't until March of last year, 2023, that a mission would last for over a year. NASA astronaut Frank Rubio and cosmonauts Sergei Propryanov and Dmitry Pratelin, launched in September of 2022, with everyone thinking they were going to do the normal 6 months. However, 3 months in, they discovered their return Soyuz spaceship had suffered a coolant leak, and so it could not safely return them back to Earth. A rescue Soyuz was brought online back here on Earth and launched without crew in order to bring the astronauts home. And that took 2 months. So it launched in February of 2023. But that spacecraft was supposed to be the one used by the next International Space Station crew to arrive in March. And as we just found out, it would be at least 2 months before another Soyuz could be readied for launch, making the earliest crew exchange possible April or May of last year. So a decision was made to keep the ISS crew rotation schedule on track, which meant instead of coming home as scheduled or even a few months late, Rubio, Propryanov, and Pratelin were unexpectedly staying for another 6 months until September 2023. Their mission ended up being 371 days, so 6 days longer than a full year. Now, thanks to these 5 missions, NASA has been able to provide a consistent understanding of how the human body changes in space. And so medicine is able to define the normal reaction and adaptation of humans in long-term spaceflight. Rubio also participated in a study examining how exercising with limited gym equipment affects the human body, since future crews to the moon and Mars will not have enough room on their spacecraft for a treadmill, which is the mainstay of astronaut exercise. Rubio exercised only on the space station's bicycle and weightlifting machine. Okay, on to Mars. As I said back near the beginning of this presentation, everything Artemis is doing, what we're doing at the moon, is what we expect the currently unnamed missions to Mars will be doing at Mars. So the first human mission to Mars is expected to be only in orbit of Mars before returning home via the Gateway space station at the moon. Then subsequent manned missions to Mars are expected to involve 3 or maybe 4 humans, out of which 2 humans will land on Mars. The other 1 will remain in orbit to retrieve the 2 that land. So yes, no humans have ever been to or on Mars, so there are no firsthand accounts I can give you. However, NASA has had 4 landers, 5 rovers, and 1 helicopter drone. Roscosmos has had a lander, and CNSA, which is the China National Space Agency, has had 1 rover and 1 deployable camera. All of these have provided us very interesting information about Mars. So I have to start with my most favorite picture ever from Mars. Here on the left is a sunset on Earth. I don't know who took the picture. And on the right is a sunset taken on Mars by the Spirit rover in 2005. NASA states, the bluish glow in the sky above the sun would be visible to us humans if we were there. So, here on Earth, we have a blue atmosphere, and that causes our sunrises and sunsets to be reddish. Mars has a red atmosphere, and due to the same color physics, that makes Martian sunrises and sunsets blue. And yes, the sun does appear smaller on Mars. In 2023, the Curiosity rover showed us that sun rays happen on Martian clouds like they do on Earth clouds too, which is pretty cool. Except it turns out that there's so little water in the atmosphere on Mars that clouds are exceedingly rare. If they do appear, it's only at the equator and only during the coldest part of the year. But which for amateur astronomers like myself means that the night skies on Mars are almost always clear and full of stars. Speaking of seeing things in the Martian sky, Mars has 2 small moons, Phobos, only 14 miles wide, and Deimos, a similar but smaller 7 miles wide. Due to being much closer to Mars than our moon is to Earth, both are visible in the Martian sky like our moon is visible. From the surface of Mars, Phobos appears half the size that the Earth's moon appears to us when we look from the surface of Earth. So here's an image to give you the relationship visually. And that back there is Deimos behind Phobos. As you can see, both of these moons are too small to cause solar eclipses like we are treated to here on Earth. But here is a video captured by the Perseverance rover in 2022 of Phobos transiting the sun. So transiting means to pass in front of. So clearly, the sun will visibly diminish in light to the surface of Mars, similar to when a cloud on Earth transits the sun, a thick enough cloud. Phobos orbits Mars 3 times a day. That is, it can be seen rising and setting 3 times every day. But it orbits so close to the planet's surface that in some locations on Mars, it can't always be seen while it's up. Deimos orbits Mars 30 hours. So every 5th day, it does not even rise during a 24-hour cycle. The math on these orbits of the two moons is more than I'm going to get into. But the interesting part is that someone near Mars's equator on the right nights that Deimos is up can see eclipses of Deimos by Phobos every 10.25 hours. In 2013, the Curiosity rover took 41 images of such an event occurring, and they were put together for this video. I keep saying 24 hours. A day on Mars actually lasts 24 hours and 37 minutes. So a human's body and mind would hardly have to adjust to that time change at all, which is very handy. A year on Mars, however, is about 687 days, which is 1.88 Earth years. That's a little less than 2. However, Mars has 4 seasons, just like Earth does, the same 4, and for the exact same reason. Mars is tilted on its axis 25%. Earth is tilted on Earth's axis 23.5%. Very close. Putting all of these different times together means that the experience of days and seasons on Mars will be vastly familiar. Single difference being 1 year, and thus the seasons themselves, last almost twice as long on Mars as they do here. Although since the pandemic, I'm not even sure I know what a year feels like anymore anyway. So I have it on decent authority that this watch, which does run on Martian time, is what previous Mars rover, lander, and orbiter mission workers were given one time by NASA. And that it drove this man's friend's family crazy when this NASA worker would slip into Martian time while he was at home. But anyways, as of today, we do not know how long the first humans on Mars will be staying on Mars. That will be a decision made in a decade or so, sometime much closer to the actual mission. It will have to balance both that it takes a long time to get to Mars, and so we will want to stay as long as we can, right, to get as much information as we can, with that astronauts on long duration missions of a year have shown definitive levels of homesickness and maybe becoming stir crazy. So we will want to limit the length of time our astronauts are off Earth. Delicate balance, they will figure it out, I have confidence. Mars's atmosphere, very different from Earth. Not only the visible color difference, but Mars has a very different temperature range, air density, and air chemistry. Firstly, Martian temperatures range from as high as 70 degrees Fahrenheit, so 20 Celsius, to as low as about negative 225 Fahrenheit, which is negative 153 Celsius. The average surface temperature is around negative 81 Fahrenheit, which is negative 63 Celsius. But that's not a regional variation that occurs like on Earth. That's a daily variation. In addition, the Martian atmosphere is so thin that heat from the sun easily escapes the planet, which causes an average of 40 degree Fahrenheit temperature variation at the same spot, simply going up 2 meters, which is about 6 feet. That means that if an adult human were to stand on the surface of Mars at the equator at noon, could be 75 degrees Fahrenheit or 24 degrees Celsius at that person's feet, and would be about 32 degrees Fahrenheit or 0 Celsius at that person's head. Not even moving. Crazy. On Mars, carbon dioxide, 96% of the air, and oxygen is only 0.1% of the air. On Earth, oxygen is 21% of our air. For humans, if oxygen becomes less than 15%, a human will experience faulty judgment, intermittent breathing, and exhaustion, even just standing up from a sitting position. Breathing air that contains less than 6% oxygen causes near instant death in a human. So we know humans cannot breathe Martian air. We will suffocate. But the differences between the Martian air and the air on Earth also have three main effects on the sounds a human's ears would hear. First, speed of sound. Sounds emitted in the cold Martian atmosphere will take slightly longer to get to your ear. Due to the cold, Mars has a lower speed of sound. Humans probably wouldn't notice that when they're close to each other talking, but over long distances, it might be noticeable. Second, volume. The sound level heard would be automatically lower on Mars. The Martian atmosphere is about 100 times less dense than on Earth, meaning Mars has 1% the amount of total atmosphere that Earth has. And that affects how sound waves travel from their source to the recipient, resulting in a softer signal. So on Mars, a human would have to be much closer to the source of a sound to hear it at the same distance that we could hear it back on Earth. And lastly, quality of sound. The 96% carbon dioxide atmosphere absorbs a lot of higher pitched sounds than Earth's atmosphere does. Therefore, only lower pitched sounds will travel the long distances that we're used to. As with the speed of sound, the loss of higher pitched sounds will be more noticeable the further away you are from the source. But of course, whenever a human does finally set foot on Mars, that human will have a spacesuit on, which means conversations between humans reaching human ears will be clear, no problems, due to radio communication in the suits. But for science, NASA installed 2 microphones on the Perseverance rover. And so we have actual recordings of sounds on Mars.
The Perseverance rover has 2 microphones that record sounds on Mars. This is the actual audio of a Martian dust devil. And this is a recording of the Ingenuity helicopter in flight.
Oh, that was a little hard to hear.
This is the sound of the Perseverance rover driving on its metal wheels.
And lastly, gravity on Mars. It's only 38% that of Earth's, which is much better than the moon. A human on Mars will not be bounding up and down as much with each step as they do on the moon. Though while that person will feel solidly pulled down to the ground, moving around on Mars will be for at first. A NASA spokesperson told Space.com in 2015 that it's expected that running and fast movements will probably take quite a bit of relearning by the humans that land on Mars. The 2014 ESA study showed the ideal walking speed on Mars will be only a little more than half of the ideal walking speed on Earth, which means humans will be walking slower when they're on Mars. And as a side note, an astute internet poster calculated that a human on Mars in an oxygen-filled room could dunk a basketball on a 26.5-foot high hoop. That's about all we know for being on Mars, a human being on Mars. What else do you all want to know? It's time for questions. Do I have my co-presenter here?
Yeah, I'm here, Jennifer. Thanks so much for that presentation. Let's see if anyone does have a question. They could post it directly into chat, and Jennifer and I will have a look. I guess while they're thinking some up, I'll ask you one, Jennifer.
Sure.
How close have you come to considering trying to become an astronaut yourself?
I actually applied.
That's amazing.
Yeah. 11 years ago, yes. I applied to be an astronaut. I got a handy little postcard back saying I was qualified, and explaining the process is that there are people who apply are placed into 3 buckets: unqualified, qualified, and highly qualified. And so I surmised that since I was in that middle bucket of qualified and not highly qualified, that I probably wasn't going to get a call, and I didn't.
Too bad. Too bad. Okay, it looks like there might actually be a question from the audience now. We got one from David. What is the most fundamental reason for this expensive endeavor? How do you answer that, Jennifer? Why are we spending so much to do this?
Well, there are a variety of reasons. The most fundamental reason, though, is probably just the basic human desire to explore and uncover the unknown.
I'll take it. Here's another one. I got one from Jan. Will the crew grow food on Mars or take it all with them?
Very good question. They will have to grow it. There's not enough room nor enough thrust to get it off the ground. The amount, the volume, the density of food, even dehydrated, but then you have the problem of water, that the crew would need 6 months there, 6 months back, however long on Mars. So many experiments on the International Space Station have already begun to address that issue. Astronauts have successfully grown edible tomatoes in space, and they're working on other types of food that can be grown, and all of it without soil.
Interesting. So here's one from Claudia. What do you think of the movie The Martian? Does it make you apprehensive about colonizing Mars?
No.
Not apprehensive. Okay.
Not apprehensive. So I cannot speak for NASA on that. I can only give my personal opinion. I can note that NASA was consulted for the movie. Otherwise, the NASA logo would not have been allowed to be used. There is one very big scientific inaccuracy, which was forgiven because it was necessary for the story, which is the I was going to say sandstorms, but yeah, effectively on Mars, the dust storms are not forceful. If you were standing on Mars and a dust storm, even one of the most severe ones came up, it wouldn't even push you. You'd feel it like a soft breeze. And that's because of how thin the atmosphere is. The story, of course, needed it to be more forceful. But everything else was really good, pretty accurate. Especially the NASA hates fire, the whole don't dig up the nuclear reactor thing, that a lot of, but no, it doesn't put us off. There's always danger. We know that. Again, NASA's trying to mitigate as much as possible, but people want to go. Some people even want to live there. Someday it's going to happen.
So here's one that is an interesting thought. So these astronauts are away. How does NASA support their families while they're away and they're gone for so long?
No, that's a really great question. Most people don't even think about that. Well, one of the ways is to actually keep the astronauts and their family in communication. So the further away, of course, they get, the less they're going to be able to do live streaming, but they can do data dumps. They can record videos and share them back and forth. That's one of the biggest ones. For the families here, there's some information sharing, but of course there's a lot of confidential stuff, and also there's a certain amount of uncertainty, but they are supported as best they can be.
Okay, that was a question from Shelley, by the way. I forgot to mention who that was. And then Robert is asking, he first of all says, great presentation, Jennifer.
Oh, thank you.
How likely is the timeline for the Mars mission? Any guesses there?
Again, personal opinion, but as I look back through NASA's history, space shuttles, and the International Space Station, the telescopes, none of it's been on time for various different reasons. But I mean, as a software developer, which is completely unrelated to space travel and completely less dangerous, we were hard pressed to get things out on time, right? Like there's a reason software development has moved to agile and away from agreeing to a date before anything is actually built and written. So, go when you're ready, as opposed to promising a date and then can we make it? That's software development shift. It obviously NASA and space exploration hasn't made that shift, and they can't be multiple things. But yeah, I didn't see Artemis 2 getting out before 2025, and now that's where we're at. So I am hopeful for Artemis 2 for 2025. I personally, non-NASA affiliated, would say Artemis 3 is not getting off the ground in 2026, but that's what we're scheduled for, and that's what we're hoping for.
Okay. So here's a follow-up question from Jan. She asked about the food before and growing things. What about water supply? Are they going to be able to get water from the surface of Mars and use it in any way, or they have to bring all their water along with them?
They can't. We can't bring water. So, yes, there is water on Mars. It is pretty much all ice. It is underground, but in some places it's actually not very far underground, just a couple miles. So the expectation is we will be drawing water from Mars somewhere. However, is Moxie the name of it? There's a project going on right now that on Mars that has tested creating oxygen from the atmosphere and from what's available on Mars, and it has succeeded. So very happy. We shouldn't have to send oxygen along for breathing. We should be able to generate it there and in enough quantities. But the next extension is if we can generate the oxygen, can we generate water also? So there will be other projects, tests, experiments to see if maybe we can generate water out of what's available on Mars. But no, we can't send it. It's too resource limiting.
Got it. So here's one from David. What is the projected cost in trillions, he's asking, for the, I don't know if it is that high, for the total mission? Couldn't this money be better used on Earth?
I have no idea what the projected cost is. I don't follow the money numbers. It's just outside of my comprehension, as a lower middle income American. Better spent on Earth. Of course it could be. And there's trillions of dollars on Earth that could be better spent on Earth that aren't.
That's a pretty good point. All right. So he's asking again, another question from David. Why has there been over 50 years between trips to the moon?
That is the question, right? Why has it taken us so long to go back? I don't have a good answer for that. One was that we turned our attention from the moon, which was amazingly money intensive, time intensive, resource intensive on the nation. And we got the information we could get. We made the exploration. We made ourselves, the first one there. And there were so many more milestones and firsts that could be done here in Earth's orbit. And there was so much more collaboration that could be done closer to home than on the moon with the technology at the time. It was just better cost, better politics, better benefits to stay close to home. For
Here's
50
one.
years, I don't know, but
So here's one from Christina. Will the Mars mission need to stop at an international space station before reaching Mars, or is it a straight flight?
oh yes, it will stop at the Gateway International Space Station around the moon.
Right. That
So
seems to be the point. So
yeah, so the original plan was to launch from Earth to the International Space Station here, then travel from there to one around the moon and then to Mars. But the plans now have eliminated the International Space Station stop here around the Earth. So they'll go straight from Earth to the space station that orbits the moon, and then from there out to Mars.
I see. Okay. Here's one from Susan. Is the heat shield problem solved yet?
That has not been made known to us solar system ambassadors if they have a solution or not yet.
Okay. They don't share everything with you. Okay.
Oh, they do. It's just a matter of how long it takes. Like I said, we're not paid employees. We don't have the security background, right? So like it takes time for that information to filter down to us.
I see. Okay. Let's see. Claudia, what about the danger of bringing back bacteria or microorganisms that could be deadly to Earth life?
Yes, very good question. So I actually did a presentation about this a couple years back. Planetary protection, their department. And most of it is about making sure we do not contaminate what's out there. But there is a small part of that. We need to protect Earth and what's coming back, right? So there hasn't been much coming back except for from the moon. And originally they took big steps, and science has proven that the moon is a product of the Earth. There's, I mean, millions of years it's been out and away from us, but all the basic chemistry and everything is the same. So we're no longer concerned about passing things from the moon to Earth and back. The concern does remain for Mars. And as they are planning the Mars sample return missions, which might get accomplished before we can get humans out there, if we can get robots onto the planet to pick up those samples and then return them to us. There are procedures and mitigations in place for how we collect them, where we can open them, what level of protection and cleanliness needs to happen. And all of those are being used right now on the asteroid return samples that both JAXA, so Japan, and the United States are working with.
Let's see. We've got time for maybe a few more questions. This question I'm not sure I understand, but I'll read it. It says, will there be international space stations as well? I'm not sure if they mean orbiting Mars or, oh yeah, what are your thoughts on other space stations being built?
They're already being built. So a lot of things, there's a lot of stuff. The United States and Russia, the foremost main partners of the current International Space Station. That space station is exceeding its lifespan, which is fine. It's doing very well. It's being maintained. But there are plans to sunset it, especially since Gateway is going to become our focus. I mentioned the four main partners for Gateway. United Arab Emirates, JAXA, ESA, of course, and then of course CSA, the Canadian Space Agency, has a hand in everything because they're the foremost on space robots. Everybody's got them. However, China already has their own space station up, and it looks like there are talks forming between a few nations to build their own space station independent of the International Space Station orbiting the Earth. So it would still be an International Space Station, but it would not be with NASA and ESA. Where ISRO lands on that, we don't know yet. That's the Indian Space Organization. They're becoming a big powerhouse, but they are very cooperative on both sides. Yeah, there's going to be multiple of them. Around the moon, that's a different question. I mean, it's a whole other level of technology. and, effort to get to the moon as compared to low Earth orbit. As for Mars, who knows? We're just trying to get somebody there and back safely.
Yeah.
People are talking about colonizing Mars, but that is, that's still science fiction.
Here's one question from Jan. Are we going to Mars with other countries or just the USA?
We are going with other countries. We're going with Canada. We are going with ESA. And the Artemis Accords has, gosh, I can't remember. I want to say it's 16 nations signed on to it now, which is more about the moon than Mars. But there's definitely nations signing on to help get to and come back from Mars.
Taking a look, see if there's any more we could squeeze in. I think that might have been the last question we'll take tonight. So on that note, let me just conclude by reading the last comment here. Thank you so much for your presentation, Jennifer, and thank you everyone in our audience for joining us this evening and for submitting your questions. I hope you enjoyed this program. Good night, everyone.
Good night. Thank you.